This video talks about X-linked genetics question, and the question says that a 26-year-old woman with mild hemophilia, okay, she's hemophilic, that means she's suffering from an X-linked disease maybe, right? Because hemophilia 8 and 9 are both X-linked, is found to have a heterozygous carrier of a mutation in the X-linked factor gene. So one of the X-linked is going to be disease. So let's say the big X is going to be the normal one, and small x, and this small x is the diseased one. Okay, so again, a 26-year-old woman with mild hemophilia is found to have a heterozygous carrier of a mutation in the X-linked factor gene. An increased proportion of the X chromosome carrying the mutation are active. So we are seeing more and more of this one X being more active. Okay, and it's asking for why. Explain this phenomena. So what we have to understand here is that in a female there are two X's, right? Okay, and one of them is going to be inactivated by lionization. Okay, so only one of them is really active and the other one turns into bar bodies. Okay, but in a male we have X and Y. There is no chance of any bar bodies. If there is bar bodies, then this patient is going to have no sex chromosome. Half is going to be missing. So let's say that in this patient the mutated X chromosome was passed on to the male. The male has no choice. The male is going to have the disease for sure. So that's why we see X-linked disease in male. But what about female? Let's say this is the one that converted into bar bodies. This is the one that got inactivated. We are not going to really see anything in this patient at all. We are going to see that this patient is normal, even though this patient was initially a carrier. But what about this did not happen? What about if this was the chromosome of the lady and if the normal one got inactivated? It can happen because it's a random choice, right? If the normal X becomes inactivated more often than the one that is carrying the mutation, we're going to see that the patient is suffering from the disease, right? So if more of the X chromosome carrying the mutation, if more of the X chromosome carrying the mutation is active, only then we are going to see an increased proportion of the X chromosome in this patient. So we're going to see that this patient is, even though this patient is a heterozygous carrier, we're going to see some effects of the mutation depending on which one is activated. In this case, we have to say that it is the normal X chromosome which was inactivated rather than the mutated one. Okay, or more of the normal got inactivated than the mutated one, giving us some of the symptoms of hemophilia.